PAW 8000 is a web application for interactive machine learning for time series forecast. It speeds up the process of experimenting with different models through its interactive user interface and helps with the understanding of the underlying model through numerous visualizations. The landing page summarizes the features of the web platform. All of the datasets used for experimentation can be uploaded to the cloud and accessed from anywhere. The platform features an intuitively configurable neural network for the experimentation process. The forecasting graph visualizes the model's performance based on the test data. The weights of the neural network are visualized according to their magnitude. During the training process, a live loss graph is visualized. Referring to past values for forecasting has been made accessible by the time warp feature. Getting started is as easy as creating an account, uploading the dataset, configuring the neural network, and analyzing the results. Creating an account is quite straightforward and is done by completing the form. To upload a dataset for experimentation, we use the following prompt. Here we have a CSV file for the S&P 500 index, separated by days, roughly for 3 years. Once the upload is complete, we simply click on the dataset to launch the interactive machine learning page. The columns are automatically recognized based on the CSV header. We can specify inputs to the neural network by simply clicking on the labeled node, and similarly, we can specify what we would like to predict by clicking on the output nodes. The user can adjust the number of nodes for each layer with the associated plus and minus controls, and adjusting the number of layers is done with the same plus and minus control fashion. Let's see if we can predict the highest price of the day based on the opening price. We can easily change the hyperparameters of the model, and let's go and change the number of epochs to 10. Here we can adjust the activation function, and we can adjust the train and test split ratio. Let's train the neural network with the current configuration. And here we see a live training graph of each epoch and the loss associated with each badge in that specific epoch. You can see how the neural network has its weights animated so that it specifies the flow of the feedforward neural network. Once the training has been complete, the user can inspect the forecasting graph as well as the weights of the trained model. This one didn't do so well, so let's try another one. To refer to past values of a specific column, we can use the time warp feature, and here we select which column we would like to refer to and specify the time lag. This feature automatically creates a new node which is added to the input layer. This way, what we like to do is predict the high price based on the opening price and the high prices of the previous 2 days. Let's increase the number of epochs, and we can also enable the fast training using the settings panel. It disables the live training graph and reduces the overhead for the backend, which allows for faster training. Nevertheless, we still have the live loss graph, and you can see it in action. Prediction graph is updated with the new model's predictions, and we can immediately see the model is more accurate than the previous one. Here we can inspect again the individual weights, and in order to remove the clutter from the visualization, we can make it so that the only selected input and output columns are visualized by clicking the visibility icon. This makes the visualization clearer, and we can also inspect the individual biases by hovering over the small square next to each neuron. Using a different dataset, we enable the scatterplot graph, which creates a new tab. It contains a correlation matrix, and clicking on an individual square visualizes the corresponding graph.